The third characteristic that we're going to have a proof for is that the consecutive angles of a parallelogram will always be supplementary, which means they add up to 180. And as I do these proofs, I want you to keep in mind that just because I present it in one way or one proof, that doesn't mean it's the only way. There are other ways of proving what I just did in the previous problem and the problem before that. But I'm just pointing out the way that made the most sense to me, or maybe the most logical to me, and you may come up with other ways of proving the exact same information that I'm doing. But again, I'm just presenting an argument. This argument needs to be sound in both logic and in facts. So let's start off on characteristic number 3. It says that consecutive angles of a parallelogram are supplementary. So what I want to make sure is that when I take angle A and I add it to angle D, I have to get 180. And as I walk around, or as I go around this, D plus C has to equal 180, and C plus B has to equal 180, and then back around, B plus A equals 180. So my job is to prove that all of these angles will always end up adding up to 180. So again, we're going to start off with the known fact that we're going to start with a parallelogram. So ABCD is a parallelogram, and that is given. If we're given it's a parallelogram, then I already have in the picture that the opposite sides are parallel. Well, when opposite sides are parallel, we have 5 special angle relationships that we studied earlier in the year. And I'm going to use the red lines. I'm going to use those as a point of emphasis. If my red lines are parallel, then this angle here, A, and this angle, D, end up having a special name, and they were called same-side interior angles. And we've learned from Unit 1, the same-side interior angles are always supplementary. So what I can look at is that angle A plus angle D has to equal 180 because of our known fact that we got from Unit 1, and we call that the same-side interior angle theorem. To try to cut down some of our writing, we inserted these acronyms instead. So now what we can do is we can say, well, let's work around our parallelogram. Since angle D is next one in this order would be angle C, does angle D plus angle C have to be adding up to 180? Well, now I'm going to use the fact that the blue lines are parallel, and that means that D and C are on the inside of the parallel line. They're on the same side of the transversal, so by the same nature, we know that angle D plus angle C is equal to 180. And that is by the same side interior angle theorem. And basically, you could work around the entire parallelogram just that way. But I also know from, and this is where I might deviate from what others might do, is that angle B is the same as angle D. So angle D and angle B have to be the same. And I also know that angle A and angle C have to be the same, because they are opposite angles of a parallelogram are always congruent. So that means if I know that D plus C equals 180, and C, and we do this, B is the same as D, I can replace that D with angle B. So I'm really coming down from step 3, and I'm making a substitution. I'm taking out angle D, and I'm putting in an angle B, plus the angle C has to equal 180. That's by substitution. Property of equality. So now I've just connected C to B. I want to connect B to A, but I also know from the statement here that A is the same as C. There's no reason why I can't take out angle C and replace it with an A. So I'm going to make sure I'm getting the looks in here. I want B and A to end up being 180. And D is the same as B. Here's what I needed right here. I'm going to take the angle B out in statement number 2, and I want angle A plus, take out the angle D, which means it's equal to angle B, is 180. And again, I can use substitution, or in this case, I'm going to use a ditto. So therefore, we've proven that the consecutive angles of a parallelogram are always supplementary. So that's our third trait or characteristic that will always be true about parallelograms.